Jai Hind viewers, myself Dr. Sukhwinder Singh, and today I'm going to discuss the next topic from Unit 3, that is 3 and 4 point starter for DC motor. In this particular lecture, we are going to discuss about what is the need of starter, and after that we are going to discuss 3-point starter as well as 4-point starter. In this lecture, I'm going to discuss what are the particular disadvantage of 3-point starter and why we are using 4-point starter for a particular application of speed control. Let's proceed for the first of all need for starter in the case of DC motor. As we know that in the case of DC motor, the armature resistance is very small, that is the order of below 1 ohm, that is almost below 1 ohm. This is the main cause, because we have the resistance of the order of less than 1 ohm, and that's why we know that in the case of DC motor, the EMF you can say voltage equation for DC motor is given by, that is VDC, that is the supply voltage, is equals to back EMF plus IA into RA. Okay, and from this particular equation, that is the voltage equation, we can get what is the value of armature current is given by VDC minus EB divided by RA. Okay, as we know that the particular resistance of the armature circuit is very small, of the order of less than 1 ohm. That's why what will happen, this current, IA current at starting, first of all let me write at starting the particular speed of the motor is 0, that is the rotor speed is 0, and we know that back EMF induced in the DC motor, that is phi Z N P upon 60A is the relation, 60A volt, okay, as you already know. And in this case, at starting the speed is 0, that's why the back EMF is equals to 0. And due to this back EMF is equals to 0, what we have is IA comes out to be, we know that that is the VDC, means supply voltage. VDC approximately we take near about 230 volt DC, and we are considering that armature resistance is of 0.25 ohm, like that is less than 1 ohm. I'm taking an example, just an example. Due to that, this comes out to be 230 volt minus this back EMF at starting is 0. That's why when we are going to divide this by 0.25, the current magnitude is very large magnitude, very large amount of current will flow through the armature circuit, okay, through the armature circuit. That's why our armature winding may gets damaged. Due to this high inrush current. So in order to control that high amount of current at starting, what we have to do is we need to connect this particular resistance in the form of starter, as shown in this diagram. You can see over here, what we have is, in this particular diagram, we are going to add the resistance in series with the armature circuit. This whole resistance gonna be added to the armature circuit in order to control the current at starting in this way. IA is equals to, this is a particular VDC again. We know that our back EMF is almost 0 at starting. How we can reduce the magnitude of input current at starting? That is with the help of armature resistance. It is always there, armature resistance, and the starter resistance. Okay, you can see over here, these are the particular conducting studs made up of brass. These are the conducting studs, okay, and in between each of between these two studs, there will be a resistance. You can consider like this is 20 ohm between 1 and 2. Similarly, between 2 and 3, 3 and 4, 4 and 5, 5, 6, and approximately these are the 10 studs. Okay, and the approximated resistance, approximately it is near to 200 ohm. So this 200 ohm at starting is going to be added to the armature resistance, and we are able to reduce this magnitude of current like this. IA comes out to be, in this case, IA comes out to be 230 divided by 200 plus 0.2 0.25 ohm. That is the armature resistance. In this way, we are able to control the current at starting in the DC motor, and this is for the safety of the DC motor at the starting with the help of this particular starter. So in this case, that's why the starter's resistance is added in series with the armature resistance circuit or armature circuit in order to minimize the magnitude of armature current. So this is the most important point why we need starter, okay, at starting. Now in this particular starter, as per the construction point of view, what are the various elements are included in this starter? You can see this is the handle, this is the particular handle. We are going to move like this from this side to off side to on side, okay. And then these are the studs, as I already explained. This is the brass conducting path for the field circuit. This is the 3-point starter just, okay. And then this line voltage, positive terminal is going towards the line terminal of the starter, and then this particular supply positive terminal will flow through this particular electromagnet, that is known as overload release coil. That is also known as OLC, overload release coil. It is for the protection purpose for the DC motor when there will be a very high load current on the shaft of the motor. When we put some load on the shaft of the motor beyond the capacity of the motor, then there will be overload, and to avoid that kind of situation for the motor and to protect the motor from this kind of overload current, we have this overload release. And then there will be electromagnet attraction type you can say protection system we have employed over here. This is particular iron piece is attached, okay. When there will be overload, then this electromagnet comes into the picture. Otherwise it is remains in the off state, it is normally in the off state. Then we have this particular line terminal comes over here, and through the handle it comes to this particular brass, and then when it is switch on, it comes to the stud number 1, okay. So this is the purpose of this. And then when we are going to start this motor, we have to move the stud like in this manner. When we are going to moving across these studs, these resistance are gonna be cut off, okay. And the whole supply voltage come across the particular armature terminals when it is held by this particular another electromagnet, that is known as no voltage release coil, that is NVC. This is known as no voltage release coil. And in this circuit, as we know that in this electromagnet, through this particular brass conducting path, there is a positive terminal also coming through this electromagnet, and it is connected in series. This particular coil of this no voltage release electromagnet is connected in series with the field winding of the armature DC shunt motor, okay. This is the field winding of the DC shunt motor, and this field winding, this whole field winding setup is connected in series with this particular no voltage coil release, okay. And the another two terminals are connected in this manner so as to have this particular another protection, which is also with the help of this electromagnet. When there will be a overload release, then this particular armature is attracted, and then this particular two terminals are going to be short circuited. As these two terminals going to be short circuited, the current in this coil is bypass and it is comes through the short circuit terminal. As the current bypass this electromagnet, this particular handle which was previously in this on position gonna be pushed back with the help of this particular spring force. This is the mechanism of starter. We have two type of protections applied in this particular starter. One is known as no voltage release and the second one is known as overload current release. Okay, let's proceed further for the more detail. You can see in this diagram, first of all, at the starting point or at the starting of the DC motor, this stud is moved, suppose on the stud 1. Okay, then what will happen, this whole resistance of the starter is going to be added up into the armature circuit having the resistance Ra. You can see over here, Ia is controlled in this manner, VDC minus 0, there is no back EMF at starting, it is starter resistance plus this is Ra, armature resistance. Okay, as I already discussed detail in the previous slide. Now at the same time, what will happen, this whole particular terminal voltage or sorry supply voltage is come across this field winding through this, as the negative terminal is common for the field winding and the armature terminal, here we have the double A or this one is A and this one is double Z and this one is the Z for the field winding. These are the terminal notations, field and the armature. And you can see over here what will be the field current, that is comes out to be VDC divided by whatever the resistance of the field winding plus this rheostat is connected in order to control the current in the field winding as per the requirement of the speed, whether we want the speed above the rated speed or below the rated speed. We have previously mentioned this rheostat for that purpose. Now you can see over here, this is the rheostat resistance and we can control this current of field in this manner. Okay, now what will happen, as we get the on position and due to there are two protection system, protections are also provided in this particular 3-point starter. One is known as no voltage release coil. No voltage release coil means if there is due to any reason there is a cutoff of input supply, then this electromagnet is going to be de-energized because there is no supply in this electromagnet and this particular handle push back with the help of this spring force. That is the mechanism of no voltage release. Okay, then it may be due to the any you can say open circuit in the field winding, then there will be again no voltage release will de-energized and this particular handle push back. This is due to two reasons. One is from supply side, second is from the field side. If there is any particular open circuit condition is there, and another particular protection is known as overload release. Okay, in this overload release mechanism, what will happen, if there is any shaft load increment in the shaft load, what will happen, this armature current is going to be raised because this load current is going to be increased from the supply. This load current is consist of, we know that, field current plus armature current. As I put some load on the shaft, overload the machine, then this Ia gonna be increased. Okay, and the field current remains constant, but in the overall effect, which current is going to be increased? That is the load current. And in order to avoid that kind of overload situation, this particular electromagnet now has the current flowing through this coil is increased beyond the capacity of the motor current. Then this will attract this iron which is put over here, and due to this particular movement into the upward direction by this electromagnet, these 2 points are short circuited by this triangular iron. Okay, as these two terminals are short circuited, then the whole current which is previously flows through this particular no volt coil release to hold this particular handle. Now it is bypass and it comes through this one, comes like this one and bypass this particular electromagnet, and hence there is no current in this electromagnet. It is de-energized and again it is pushed back by this particular spiral spring. This is the spring force in order to take the particular off position, okay, so as to protect the motor from the overload condition. So these are the particular points regarding the 3-point starter. Now I am gonna discuss what is the disadvantage of this 3-point starter in the case of speed control when we are when we want the speed above the base speed, because in that case we know that there is a relation of speed, that is speed is directly proportional to back EMF divided by the flux. To increase the speed, what we have to do is we need to decrease the flux. Okay, as we are going to increase this rheostat, the field current which is flowing through this particular coil of field winding is required to decrease in order to obtain the speed above the rated speed. When the case is speed above the rated speed, what we have to do is we have to reduce down this field current. Okay, as this field winding is connected in series with the no voltage release circuit, also the current through this electromagnet is also going to be decreased as we are approaching the speed above the rated speed. Due to this decrement in field current, again due to this field current decrement, the automatic reaction on this particular electromagnet current is also decreased. That's why this is will release this handle and the spring force. Okay, you can write over here the force of springs is greater than the force exerted by the electromagnet. Okay, as the spring force increased as compared to the electromagnet force, this particular handle push back and the whole system is off. So this is the particular reason why we are not opting 3-point starter when we are approaching speed above the rated speed. Now come to the next point. In this case, as I already discussed, this is another way of connecting the 3-point starter. In this, there is no particular brass conducting path is available. Only the resistances are connected and one particular connection is given to the field winding in the same manner. But now instead of having a rheostat in this circuit or field circuit, we have provided the resistance over here. Okay, when we are moving this handle from 1 to the run position, accordingly this resistance is cut from the armature circuit. When we are moving particular handle from this particular stud 1 to, as we have discussed in the previous slide, 1 to 5 or to run position, what will happen? The starter resistance is cut from the armature circuit, but the same resistance is added to the field circuit in series. This is the only particular connection that is little bit different from the previous one. In that case we are totally cut down the armature resistance, but in this case again we are cut down the resistance in the armature circuit, but the whole resistance is added to the field circuit instead of connecting the rheostat. As in the previous slide, there will be rheostat is available to control the field current, but here we have used the same starter resistance for the field circuit when it is in the on position. Okay, in the on position, the field current is controlled in such a manner that VDC divide by, it comes out to be starter resistance plus field resistance. I think it is clear to all. But in the starting position, armature current gonna be this VDC minus EB, because in the on position we have the EB is induced divided by the RA. Now this from the armature circuit we have cut down the particular resistance, but we have added automatically to the field circuit in order to have the speed control. So this is the different you can say configuration of connecting the starter of 3-point. These are the two configurations. Next come to the 4-point starter. As we know that in the previous case of 3-point starter, the field circuit is connected in series with the no voltage release. That's why when we are approaching the speed above the base speed, what will happen? Due to decrement in the field current, there will be a decrement in the electromagnet coil current, and this electromagnet coil will not able to hold this particular handle to the on position, and it is pushed back to this when we are approaching speed above the base speed. In order to compensate or in order to eliminate that kind of problem, what we have done, we have separate out the field resistance, field circuit. Okay, you can see over here, as we are going to the stud 1, this whole resistance is added to the armature resistance as we have discussed previously, and this field resistance or field circuit is having the full voltage along with the rheostat like this. But in this parallel to that, we have connected the another particular coil from here. From here we have taken the another particular terminal, that is you can say separate terminal for the electromagnet. Okay, for the electromagnet coil or no voltage release coil. So now there is now there will be a, you can say, problem of having the low field current in the case of speed above the rated speed is eliminated. Okay, now there is a constant current will flow through the electromagnet, and that will hold this position into the on position as we approaching speed above the rated speed. Now there is no problem because we have separated out the field circuit. Okay, by connecting the another circuit in parallel which is coming through the electromagnet, and we have a fixed resistance. You can see over here we have the fixed resistance, and this particular point, fourth point, is known as neutral. Okay, there is no effect of this field current on this particular coil or no voltage release. Okay, that's why we are able to control the system when we are approaching the speed above the rated speed. That is the particular aspect, and rest of the concept is same. Again we have the overload current release is there, no voltage release is there, all the functions are same, but we have added another particular branch in the parallel with the resistance R, so as to have the electromagnet to be energized in the on position, which was not possible in the case of 3-point starter, because in the case of 3-point starter what we have is the field winding is connected in series with the no voltage coil release winding. That's why we can't we can't go for the speed above the rated speed in the case of 3-point starter, but that problem is eliminated in the case of 4-point starter. So this is all about the working of 4-point starter, and this is another connection as we have discussed earlier. Okay, when we have the switch on position on the stud, this is another particular configuration of the 4-point starter, but little bit different from the previous one. Okay, now this particular connection is there as in the 3-point starter. When we are moving towards this fifth point, we are cut down the resistance from the armature and motor is running at full speed. Now the current through the field winding as well as through this particular coil is having this much of resistance, R1 plus R2 plus R3 plus R4. Okay, along with this R, but it is fixed. This current is fixed, or you can say constant, but this current is variable, which is coming flowing through the field winding, variable. Why we need this variable current? Sometimes we need speed less than the rated speed. Okay, That is the requirement of the speed control. Okay, and sometimes we need speed greater than the rated speed. Okay, for this speed greater than the rated speed, we generally offer 4-point starter. 4-point starter. So that's all. This is all about the working need of the 3-point and 4-point starter. What is the main disadvantage of the 3-point starter? I have discussed in detail. I think every point is clear to all the students. Thank you so much for watching this video. Thanks.